Symmetry. In this presentation, we'll see what the symmetry is, the lines of symmetry, the rotational symmetry, and the symmetries within shapes. Symmetry can be seen almost everywhere in daily life, for example in nature, animals, buildings, and humans. A line symmetry is a line that divides the shape in half and acts as a mirror line. For example, in this picture, in the nature, we see that there is a horizontal mirror line. In this building, there is a vertical mirror line. If we want to identify how many lines of symmetry are there in an equilateral triangle, first of all, we need to know the properties of an equilateral triangle, and for the lines of symmetry, because it has to divide the shape in half and acts as a mirror line, the following two conditions have to be satisfied. The sides and angles have to be identical when you fold the shape. The equilateral triangle has these properties, so there is a vertical mirror line, which means that it will match this angle onto this one and this side onto that one. Similarly, you can fold it from that specific angle and this one. Therefore, the equilateral triangle has three lines of symmetry. For an isosceles triangle, we know that the properties are these two sides and these two angles are equal. Therefore, you can only fold the isosceles triangle like this, which match this angle to that one and that side to this one. So there is only one line of symmetry in an isosceles triangle. The rotational symmetry is when an object is rotated and appears the same. The order of rotational symmetry that an object has is the number of times that it fits onto itself during a full rotation of 360 degrees. For example, this shape, if you rotate it from its center, we'll see that after 90 degrees will match exactly the same. After 180 degrees, 270, and 360 degrees. So the order of rotation of this shape is 4. Note that all shapes have at least one rotational symmetry, and that's when you rotate it 360 degrees. The first one has order of 1. This one has order 2 because we match up at 180 degrees and 360. Order 3 and 4. You can also use tracing paper to find the rotational symmetry by rotating the shapes from its center. For example, the first one is 2, 3, and 4. Now, one important theorem is for regular polygons. If a shape is irregular, then it has, and this one is a hexagon, it will have 6 lines of symmetry and 5 lines of symmetry for a pentagon. So what we see is that a regular polygon has the same number of lines of symmetry as its sides. The same with the rotational symmetry. You can rotate the polygon, a hexagon, 6 times, so it has order of rotation 6, and the pentagon 5 times. So we'll have order of rotation 5. So what we'll see that the regular polygon has the same order of rotation as its sides. So in general, regular polygons have the same number of lines of symmetry and the same number of rotational symmetry as its sides. If you are given a heptagon, 7 lines of symmetry, 7 rotational symmetry. Now we will find the lines of symmetry and the rotation of symmetry in shapes. The equilateral triangle has 3 lines of symmetry and 3 rotational symmetry. The isosceles triangle is 1 and 1. The scalene triangle has 0 lines of symmetry because of the properties of the shape. It has 1 rotational symmetry through 360 degrees. The square has 4 and 4 because it's a regular polygon. Rectangle has 2 with 2, rhombus 2 with 2, kite 1 with 1. The parallelogram has 0 lines of symmetry and has 2 rotational symmetry. Trapezium is 0 and 1, and the regular nonagon will be 9 with 9. So what we spot here is that if there is at least one line of symmetry, that number will match exactly with the order of rotational symmetry. But because the lines of symmetry can also be 0, the rotational symmetry can never be 0. This doesn't have to be always the same. But if there is at least one line of symmetry, it will be exactly the same with the rotational symmetry.